specific question to Mark now, and this really relates to, I guess, what's best termed as conflict materials. We've seen in the news recently the electronics industry taking a much closer look at where some of the raw materials are being sourced for devices these days, and how in certain circumstances the revenue flowing into those raw material extraction processes are being fed into conflicts, and that's being stamped on, that's being changed, which is good news. The problem is that is then going to ultimately drive some obsolescence issues, I guess. And it's interesting to know how the industry, while on one hand tackling that quite rightly, is then going to engineer the distribution and supply chain to make sure that it doesn't have a big negative impact on manufacturers. So, yeah.
I can't answer that from a perspective of a component manufacturer. The gentleman that was speaking before us probably would have been a better person to ask about that. He was up here speaking about tantalum capacitors and probably some new technologies about tantalum capacitors. Tantalum is one of those materials, the minerals that is being controlled, and at least in North America, referring to them as blood minerals. Tantalum comes from some of those same areas, so we're taking a material that's already in scarce supply and we just made it even more scarce. So what are the component manufacturers doing? I hope they're trying to come up with some technologies that wouldn't utilize tantalum, because there's probably going to be a greater shortage of it. I suspect there might even be an inclination to try to recycle some of the existing components, which goes back right into the counterfeiting situation in the first place. So what is going to be done about it? I don't know. I think component manufacturers probably were a little bit concerned when that government came out with that initiative. Not ethically, of course, it's the right thing to do, but in terms of their supply chain, I think it's going to cause some dramatic changes, particularly in tantalum, at least from my experience, in terms of the primary material there.
Okay, yeah, thanks, Mark. We're doing pretty well for time. We've got a couple of minutes. I'm just going to throw in one question of my own right at the end, which you guys aren't prepared for, so you might not have an answer. But really, it relates to a lot of the discussion regarding obsolescence and counterfeit components tends to revolve around the high-value semiconductor devices, where the money is, where the money can be made. And yet, when we're talking to our readers and when we're looking at the wider market, it would appear that there's actually an underlying issue, not just with those high-value semiconductor devices, but across the entire supply chain, including mechanical components, in safety-critical environments, aircraft, military, that sort of thing, and also even in software. Where counterfeit software is creeping into sort of mission-critical systems if you're not careful, and it's interesting to know. You guys are focusing quite rightly on the business universe. Just wondering, have you got any sort of feedback on how wide this problem goes across the whole bill of materials? Yeah.
I'll start with I'll start with one aspect of it. I will start on the electronic components. I would disagree that the highest risk components of counterfeit are the highest value components. There's not many people out there making Xilinx components. You have a fairly low risk of getting a counterfeit Xilinx component because no one else makes them. You have a higher risk of getting a recycled or a second-hand Xilinx component, or one that's been remarked with a different processing speed that would technically be a counterfeit. I think the bigger problem is in the lower end, the lower cost components of discretes, capacitors, transistors, MOSFETs. Your example previously, they're not high technology components. They're not difficult to manufacture. The materials and the engineering required to go into them is not complex. They're all alternative manufacturers to the primary brands that you're buying. There are quite a few of them displaying here this week. Doesn't mean their components aren't as good, but they're easier to find a direct cross to them. You need a good remarking technology to pass perhaps an initial visual inspection, but electrical testing, I think, on those components is much more important. But I think that the lower value components are actually the higher risk.
I would say the pricing might have some influence on what may be counterfeited, but more importantly, I would say follow the lead time trends. As the lead time stretched dramatically, this past year we've had probably 10 or 12 commodities where lead times went from 2 to 4 or 6 to 8 weeks out to 24 weeks. As soon as the lead time stretch and there's that gap in your supply chain, the people that do this for a living in Shenzhen, China, are at work 24 hours a day, whether it's a cap or a transistor or a discrete device. So they're doing the happy dance over there when U.S. or Asian manufacturers' lead times stretch. The one piece of advice I would give you is use your instincts. We've been in the purchasing and buying community for a long time. If something seems too good to be true, if things are 30 weeks and somebody can deliver it at an incredibly low price, your antennas should go up. The second thing is America 2 is a stocking distributor. If somebody quotes you 3 to 5 days, that's probably their time to remark, repin, ship it from someplace else, and get it to their refinishing plant before it ships to you. So when you have a distributor like America 2 that can ship out of stock the same day, that's a clear indication that product is already secure and may have already been tested while it's sitting in stock.
Yeah, fantastic. We're coming to the end of our session now. I've made a few notes as I've gone along, and I just wanted to sort of really summarise what we've discussed here today, just in some bullet points. We started with some amazing numbers. I think it was 4,000 plus disapproved vendors. That's a big number to keep an eye on. I guess the golden rules are quite simple, which is the secret to avoid surprises is to get that detection process in early. Find the problems as early as you can, and your life's going to be an awful lot easier. And to do that, you've got to have good communication between your engineering teams and your suppliers. You've got to understand the capabilities of the distribution partners you're working with, and make sure that those companies have got the test capabilities required from goods in all the way through to those more advanced tests, some of which were new to me. We were talking delamination tests, was it Mark that you mentioned? Yeah. Looking for independent test capabilities, in-house or outsourced, I guess. In terms of what OEMs and CMs can do internally, really it's all about planning and processes. Companies should have a quality plan, I guess, constructed with the support of experts in the field. Pick a distribution partner that's big enough and brave enough to offer the sorts of guarantees that you need in terms of your supply chain, and even look for ones that have got specific insurance in place, which I was unaware of. Think about going and doing a physical audit. Think about going to those facilities, sitting down, talking to people, looking at the processes in place. And I guess the two points at the end that certainly put me in my place, which is that it's not the high value components that are necessarily highest at risk, but I guess the medium value components that are just much easier to replicate and get into the supply chain unnoticed. That's a very obvious point that I kind of missed there. And use common sense and keep an eye on lead times, because where the lead times start to move, that's where the problems could start to emerge. And that kind of brings us to a conclusion. Don't know if you guys would like to answer any questions. Any questions out there for the last sort of couple of minutes? Any burning issues relating to the discussion we've just had? So I've got it. We'll just pass you a hand mic if that's all right. Sorry. Yeah.
Do you get any information from the manufacturers in case you find out something suspicious? I made the experience that they are not really interested in giving information about the variety of their logos, of the ways I can identify by the labels if it is an original one or a fake one. So this is very difficult because on the data sheets you can find no information about that. And so it's not easy. Sometimes you see something and you don't know exactly if it is an original label or not, or an original logo or a marking or whatever. So what are your experiences regarding this?
It's a difficult part of the inspection process because in many cases IC manufacturers especially are fabless, so they're dealing with 2 or 3 manufacturing sites, and sometimes the way things are marked are different. Even at the die level, when we do decapsulation, you'll have 2 known good parts that the die looks a little different or there's a different designator. When dealing with the independent channel, the IC manufacturers are not exactly happy that we exist, and they're not very cooperative with us in most cases. what we've done is we've hired component engineers. We have one here at the site, and what they've done is they've made contacts at most of the IC manufacturers, because the bottom line is, if the IC manufacturer took back the product from the OEM when it was excess, it wouldn't come into the open market. It does have their logo on it. There is some degree of responsibility, and we think that if they didn't take it back and we're selling it, and it's like selling a used car. Ford still made the car, or Chevrolet, or Fiat, or whoever. So it's really about finding a distributor. Will every IC manufacturer cooperate with America too? Absolutely not. But we have a large list that does, and it's really about having technical expertise on staff. I'm a sales guy at heart. I need a component engineer that can talk to the factory and get information. And even at this show today, we're coming away with another dozen or so manufacturers where they have engineers on site here where we're going to be able to get information.
I'd add a little bit onto that, in that it certainly is a frustrating situation. No, the manufacturers generally do not provide a lot of support in helping to identify or at least provide the information that would be essential in verifying components as authentic or counterfeit. It's a double-edged sword, though. The more information they give away, the easier it is for the counterfeiter to mask that part. So it'd be convenient if they gave it to us, but it would also open the door for more counterfeit devices to move into the product field. We certainly see situations, as Jim mentioned, where what we're looking at physically on a device is not on the data sheet of the component, but it is on the manufacturing spec. And I won't tell us where we got that manufacturing spec. But we do see information from manufacturers that is not consistent. We see the passive manufacturers are a little bit more supportive. Again, I think they see the proliferation more of counterfeit devices into their field, so we have seen passive manufacturers be a little bit more supportive.
Any other questions? Okay. Looks like it's it. We've kind of wrapped up just on time. So I would really like to thank you guys. Round of applause for the effort you put into that. So thank you very much.